Okay, so one more example to run through for exercise 3D, and I really like these ones because they start to bring in all the solving stuff that we've done previously with factorising, null factor law, and now we're throwing in some circular functions and double angle formula. How do I know it's a double angle formula? Pretty obvious, it's got a 2x in there, and it wants me to find out what 1x is. So I'm going to start by using the double angle formula and rewrite that sine 2x as 2 sine x cos x and make it equal to sine x. Rightio, pretty straightforward. Now we've got to be super careful here. I don't want to divide both sides by sine x. I don't want to cancel the sine x's. The reason you don't want to do this is for the same reason that I never solved these problems by dividing both sides by x, because that loses one possible solution. This is an x squared equation. When I wanted to solve these in the past, the way I did it is I made them equal to 0. I factorised, and then I said x equals 0 or x minus 1 equals 0, therefore x equals 1. And I had two solutions. Well, I've kind of got the same thing going on here. If I just cancel stuff out, I'm potentially losing one of my solutions. So what I'm going to do instead is I'm going to bring both expressions to the same side of the equal sign. And then I'm going to factorise, and the common factor here is sine x, and then I get 2 cos x minus 1 has to equal 0. And then I can say, alright, so one possibility is sine x equals 0, and we know that sine equals 0 when x is equal to 0 or pi or 2 pi. So I've got 3 possible answers so far, 1, 2, 3. Or I could work with the other bracket using the null factor law. 2 cos x minus 1 has to equal 0, in which case cos x equals a half. And when does cos equal a half? Well, I'm going to jump quickly, unit circle. I still like this method of the unit circle. Cos is a half at pi on 3. So that is pi on 3, and the other place that cos is a half is down here, and that would be 5 pi on 3. So now I end up with two other solutions. So cos x equals a half when x equals pi on 3 and 5 pi on 3. Alright. So now I ended up with, changing colours, 1, 2, 3, 4, 5 solutions that are all in my original domain of 0 to 2 pi. So I need to write that sine 2x equals sine x for x equal to 0, pi on 3, pi, 5 pi on 3, and 2 pi. Now there's other ways of doing this question as well. I'll just show you. We can visualize it using a graph. So I might try and get my calculator back up here. Let's just go to a new screen, home. I can't remember how to add a calculator. Sort of having a moment here. Graph screen, so we can have sine 2x, there's one graph, and then add a second equation. Oh, forgotten how to use this one on my iPad. The other one is sine x. Hit enter, and we can see here there is one. Oh, how can I do that? Let's try and find out analyze graph, intersection points, lower bound there, upper bound at 2 pi. 2 pi is 6.28, so about there. And you can see we've got 1, 2, no, it doesn't want to work here. 1, 2, 3, 4, 5 solutions. So you can visualize it with the graph, and you can use symmetry to solve it from there if you like as well. Or going back to what I started before, using that general formula, if you like, you could solve this sine and cos value using that general formula. So the general formula for cos, I know I'm showing you the same thing multiple different ways here, but that's always useful. So if I kind of work with this expression, cos x equals a half, let's practice using this general formula. So x would equal 2n pi plus or minus cos to the minus 1 of a half, which is 2n pi plus, now cos of a half is equal to pi on 3. So there's one option, or 2n pi minus pi on 3. So if n equals 0, I end up with pi on 3, or minus pi on 3. This one fits my domain of 0 to 2 pi. This one doesn't. If n equals 1, then I get 2 pi plus pi on 3, which equals 7 pi on 3. Or I get 2 pi minus pi on 3, which equals 5 pi on 3. This one fits my domain, this one doesn't. And I've got my solutions from that general formula. And I get to avoid any of this kind of unit circle stuff that I know spins some of you out. Anyway, that's sort of 3 different ways of solving the same problem. Don't forget the key part was I used the double angle formula first, then I factorise it and use the null factor law to solve each of the 2 factors.